Okay, so you said what, Lydia?
I think that his claim is appropriate here because because it has a negative slope or a negative association.
How many points did we have?
We had I think 9.
You had 9. So we're going to want to try to do like 4 or 5 on top, 4 or 5 below the line. And guys, if we go through one of the points, like that's okay. We don't have to count it. So look up here real quick. See that point in the middle of my graph that I'm kind of like hiding? So if I do that and I go through that middle point, how many points do I have above? 4, right? How many points do I have below? 4. So this is a pretty good approximation for my line of best fit. Now yours might have been steeper. Like, you might have maybe done something more like this, but like, I think this is a fairly good approximation. Now, what do we call it when something is like far away from what we think it should be? Outlier. What maybe, so we're saying supposedly with our line that a new vehicle is like $42,000 or a 0-mile vehicle, right? Any thoughts on like why that point maybe is like higher up than that, Lydia?
Because maybe it was like just manufactured. It was a really nice car.
Anyone's parents buy like a truck recently and complain about buying a truck? Trucks are really expensive. That's why I will never probably buy a truck, even though I do truck stuff. Like I go buy lumber and do like construction stuff. This might have been a truck versus maybe these were cars. Cars are cheaper than trucks, right? So like there's multiple reasons. Now I got another question for you. Like we made this a straight line. Does it have to be? Does every relationship have to be linear? So I want you to sketch on here what you think it would look like if we made our line a curve instead. So maybe something like this. Now wait, if we think about the graph continuing outward, right, I said my vehicle had 130,000 miles on it, so I'm like out here. If we followed the straight line, apparently my vehicle would have been worth nothing. Do we think like a vehicle turns into being worth nothing? Even if it doesn't run. Anyone know what you can do with a car to get money out of it? Harrison?
Take off the copper.
Scrap it. All the metal, you can scrap it. It's worth money no matter what. Even if it doesn't run, it's worth money. So the straight line here, even though that would be our line of best fit, it might not actually be the best to model this situation. Because like, I got some money for my car. Not a lot, but I didn't get nothing, right? I got some. So sometimes we use curves. We're not going to have to use curves this year. But next year, you will start learning how to graph curves. And by the time you're actually in high school, it's really not that difficult. It's just like, if you learn what you're supposed to learn now, it's just one more layer, right? It's not crazy, promise you. If you go play in Desmos, you could figure out how to graph curves just by playing in Desmos. All right, so we go back to Nate's questions then. What do you think a car with 80,000 miles would cost? So take a moment, use your graph. Now, I guess for that one we should use the line since most of us had our line. How could I make that prediction of what a vehicle with 80,000 miles would be worth? Anyone want to walk me through how I use my graph to do that? Vivian? Go up until what? So my blue line was like here for my 80,000, right? If I go up until I hit that line, and then Vivian said we go over. So what do we think it would approximately be worth?
16.
Yeah, like maybe 16. Maybe. Does that make sense how we use a graph like this? Is Nate's claim true? Do we think we believe him that cars with less miles are worth more? Yeah, right? I mean, that's the last question on your paper. But like, yeah, cars with less miles seem to be worth more. Now wait, his car with 23,000 miles. What do we think Nate's car is worth? So find 23. You can also use a ruler to do this, right? If you find 23 and just use your ruler to trace it up and hit our blue line. Yeah, maybe like 35, 36, somewhere around there. What about Rick's car with 31,000? What about Rick's car with 31? Yeah, a little bit less than Nate's, right? Like maybe a little over 30,000. Because so this is why we do line of best fit. So then we can make predictions. Questions?
So, hypothetically, how steep could you go until it would be like inaccurate?
Until you get to undefined. Anything not vertical is possible. Yeah, anything not vertical. Once you're vertical, then it's undefined. You have 3 minutes, 3 to 4 minutes. You should leave my room. You should go take a walk, get a drink, go to the bathroom, whatever you need to do. Here's your break, because we're blocked. So here's your break. You should leave my room just to, like, wake back up or whatever. I'm going to open the garage. When you guys come back, we're making those.
It's only 4 minutes before we get back to keeping cooler now. Winkle, you need to stop being absent.
John?
What the heck is John?
I was gonna say John Winkle. Well, Van Winkle, stop being absent or else I'm coming to your house and touching your toes. Actually,
Van Winkle.
I'm gonna do that anyway, Jack. But
Keep it
just like,
school appropriate. I am still recording.
I
I know
seriously
you're mad at Jack.
Jack needs to come back. I miss Winkle.
He said his doctor said he can't return until Monday at earliest.
Why are there so many broken rulers?
Because middle school kids like to push boundaries. I believe. Alright, so here is the dealio. Well, actually I skipped over. I got too excited and I skipped the problem. Go ahead and flip to the back of this paper. My bad. The odometer graph paper. Flip to the back of the odometer paper. Yes, the odometer paper. So, association is kind of another way to talk about slope. But again, I've got help for you on our Schoology, so we might as well go look at that for a moment. Check this out.